In this video, we're going to start learning about how to find volume, and our focus today is on volume of prisms and pyramids. So as you watch the video, please note things that you already are aware of and variables and the concepts. Make sure that you are watching videos that are linked below just to get a little bit more comfortable with the concept and what is the volume is all about. So volume is about the capacity of our three-dimensional shape. So today we're learning how many cubic units will it take to fill up our object. So in our practice, as we learn about volume, we would be filling it up with water, sand, gravel, dirt, and so on. So let's get started. This is the node that we're using, and I'm going to go ahead and zoom in. And so our first, and here we are. Well, that was too much. Okay, so we're going to start with volume of prisms. And as always, I want to make sure that you are really sticking to all of the good skills we have been practiced. We're going to highlight the bases. Okay. And we're going to identify the height. So we know that the base is a rectangular shape right here. It's 3.5 by 7. And we know that the height of our prism is 4 inches. So the height is always the distance between the bases. That's why we're taking time to highlight the bases so we can identify the height. So I hope you are realizing that we have a very familiar variables in our formula. So volume says that it is equal the product of capital B and H. So capital B, as before, is area of the base, just one. I know sometimes you are asking, is it 2 or 1, both? One area of the base, and H is our height. And I do want to make sure to still write down in our note distance between bases. Please write this down so it really, once again, really sticks with you guys. All right, so what is the area of the base? That would be the area of a rectangle. We have a rectangle as our base, so that would be 7 times 3.5, and that's going to give us 24.5 square centimeters. Our height is 4. We're ready to find our volume. 24.5 times 4 will give us 98 cubic inches. So that's going to be the new label that we're using. We're going to have cubic inches because now we're using all 3 dimensions. So we're filling it up not only on top of the base, but also filling in the height. So we're now using the 3rd dimension, and we're filling it inside. So that's going to be one of the other keywords. Inside, fill up, how much can your object hold, and so on. All right, moving on to our triangular prism. I'm going to zoom in on that. And first step, I'm going to go ahead and highlight the base that I'm working with, bases that I'm working with. And just doing some labeling to get ready so I have no doubt what's happening between all of these numbers. So 8. Now I only have one measure of 8. That means I have an equilateral triangle here, which is great. And then I have the height of 6. And that's all I really need to mark for this particular shape. So our volume formula is area of the base times the height of the shape. So area of the base would be area of triangle. So we are not forgetting that area of a triangle is dividing this product of these base and height, these two numbers, by 2. So that will give us 8 times 6 divided by 2, 24 square centimeters. So our height, I labeled it right here. It's labeled as a distance between the bases. We talked about some of these shapes are not always going to be standing up, but we are aware that height is going to be a height no matter how your shape is positioned. So we're ready to find our volume. 24 times 12 and a half will give us 300 cubic centimeters. I don't know why I wrote 2. It's a 3 cubic centimeters. All right, so we're going to continue, and we are moving on to volume of pyramids. The reason we're going over both of these shapes, or types of shapes, prisms and pyramids, today in our discussion is because we have lots of similarities in our objects and in our formulas. So let's take a look at our formula first. So capital B, are we aware what capital B is? Yes, we are. This is area of the base. Okay, so in our first shape, our rectangular pyramid, we're going to go ahead and highlight the base, and we're like, oh yes, we know what shape this is. This is the shape of a rectangle. All right, so this is my rectangle, 6 by 5. Got it. I know what that is. Okay. We notice it's only one base in this particular shape. So just one. So no guesswork. And so now we also see in the H, it's our height. So the height measure is very unique. And I hope you are seeing the difference of how it's marked. Previously, our height was on the edge of our triangle, but this height is very specific height of our shape. It comes from the top vertex, okay, where all of the sides meet up, and it goes directly to the center of your base. That is the true height. So previously, when we discussed our pyramids, we always talked about this, and this is called slant height. So this is specifically the height of the side, but we're not concerned with that anymore for the volume. Specifically for the volume, we do not need that. We need this height. How tall is this pyramid? All right, let's solve this question. So one thing I always want for you to make sure that you can do and be comfortable with these formulas. I always like to use my volume formulas in this format. So here we have 1/3 of the product of area of the base times the height. I would like for us to have a little bit more friendlier format as to, excuse me, you would have area of the base times the height and then divide this product by 3. Okay, so just wanted to make sure that you are seeing how many similarities we have here. We have area of the base times the height. We identify our base, identify our height. So now the very interesting relationship between the formulas is the pyramids are always considered to be 1/3 of the size. So as I mentioned to you earlier, I would like for you to watch a video that is attached in this module about this relationship. It's really, really cool concept. So please make sure you take a look. All right, let's walk through this question. Area of this particular base would be 5 times 6, which gives us 30 square centimeters. And so let's set up our volume because we now have all of our values. So this is our height, so we know it's 30 times 7 divided by 3. As before, just wanted to give you a hint that 3 and 30 can be reduced. So that tells you that's going to be equal in 10. I hope you're understanding. When I reduce this, that becomes a 1. So your product here is 70 over 1, which is simply a 70 centimeters cubed. right, and our last example for today is a triangular pyramid. I'm going to zoom in on this example. So triangular pyramids, not just as straightforward as the rest, but I hope you're understanding. All that means is the base is a triangle. So please make sure, stick with our practice of highlighting the base and drawing the picture of the base so you are 100% sure what numbers you're using in which steps. So my base right here, so it says 10 is this line right here, 12 is the base right here. Got it. I'm looking at my measurement right here. Goes straight from the very top vertex all the way down into the middle of my base. That's going to be my height of the shape. Okay, so I'm ready to set up my question. Volume would be area of the base times the height divided by 3. My area of the base is going to be area of a triangle. So I have 12 times 10 divided by 2. Again, why am I dividing by 2? I am simply following my formula. 6, that means area is 60 square inches. All right, so volume would be 60 times 15 divided by 3. At this point, you can reduce either number because 60 is divisible by 3 and 15 is divisible by 3. This is a fairly straightforward question and reduction right here, simplification. So that gives us 5. 60 times 5 is 300 cubic inches. So as you are going through these questions, these are great examples. They're very simple but straightforward of the shapes that you might be using for your creating my label assignment. You are welcome to reach out to me with any questions. Please make sure that you're watching additional videos for today just to see how these two formulas have proven themselves in a little experiment with actually trying compare the volume of these two shapes. Make sure you're reaching out with any questions and practicing working with volume of prisms and volume of pyramids.